Hello, in this video, we're going to be doing the second half of lesson 6.1, which continues with properties and attributes of polygons, and then also reviews some coordinate geometry with midpoints and distance formula. If you haven't already completed the day one portion of the notes, you should go and watch that video or complete those notes because this one is going to build off of what we did on day one. In the first example here, we want to find the measure of each interior angle of pentagon ABCDE. What we need to figure out first, though, is what's the total sum of the angles in the pentagon. So I'm going to do a calculation here using the formula that we discussed in day one. The sum of the interior angles of a convex polygon is equal to n minus 2 times 180, where n is the number of sides. So this pentagon has 5 sides. So we just need 5 minus 2 times 180. So 3 times 180, we need to equal 540. Well, the angles inside there have to add to 140, and you can see that we have these different algebraic expressions. So angle A is 35C, angle B is 18C, angle C is 32C. Angle D is also 32C. And angle E is 18C. So I'm taking those expressions from A, B, C, D, and E, and I'm adding them up. And because it's a pentagon, the total sum has to equal 540. And now we just do the algebra here. If you add up all of those numbers, you're going to get 135. So 135C equals 540. Divide by 135. And when we do that, we end up with 4. So C is equal to 4. But be careful, the question didn't ask us for C. It asks us for the measure of the angles in the polygon. So now we have to use that C and kind of plug it back in. So for angle A, you can see in the picture, angle A is just 35C. So if I take 35 times 4, that is measure of angle A equals 140 degrees. And then I'll do the same for B. The measure of angle B is 18C. So take 18 times 4. And when you do that, 18 times 4 is 72. Now the measure of angle C is 32C, so that's 32 times 5. And when you calculate that, it is 160. The measure of angle D is also 32C, so that's going to be the same thing, 160. And then E is 18C. We already calculated that when we did angle B. So the measure of angle E is going to also be equal to 72. Now, a way to check that these answers are correct is if we add up all of those angles, you're going to arrive at 540 degrees. The total sum of the interior angles of this pentagon is 540 degrees. Let's try another example. Notice that in this polygon here, we actually don't have the interior angles. These are all like exterior angles. And in day one, we learned that in any polygon that's convex, the total sum of the exterior angles is always 360 degrees. So if I just take the 1, 2, 3, 4, 5 angles here and I add them up, so I'm going to start at R, which is 7A, and then S, 2A, T, 3A, U is 6A, and V is 2A. If we add all of those together, the exterior angle sum is always 360 degrees. We'll combine your like terms, add all of those A's together, and you'll arrive at 20A equals 360. Do a quick divide by 20. And we end up with 18. The directions, though, ask us to find the measures of the exterior angles. So to do that, what we're going to do is just plug the numbers in. And these are the exterior angles. So technically, I don't want to call them angle R. Angle R most likely would refer to the interior angle in the polygon. So I'm going to just make a list here. So I have my exterior angles at R, S, T, U, and V. And then I'm just going to list them in order. So for V, for R, let's start at R, 7 times 18. And if you calculate 7 times 18, you are going to get 126. So angle R is the exterior at angle R is 126. Angle S is 2A. That's just 2 times 18 there. So the exterior at angle S is going to be 36 degrees. And then the exterior at T is 3A. So take 3 times 18. And when you do that, 3 times 18 is 54. So that exterior is 54. I'll move on to U next. 6A, so 6 times 18. And that makes 108. And then lastly, V is just 2A again. So 2 times 18, we already calculated before, is 36. So a way to check that you did your algebra correctly and that you did your calculations correctly is if we add up all 5 of those exterior angles, they're going to add to 360 degrees. Here's a try now for you to try on your own. Notice that this shape is a quadrilateral. We have quadrilateral PQRS. Go ahead and calculate C, and then list the measure of each of the angles. Please pause your video now and give this a try. Here's your solution to the try now. C is 45, and then if we plug in the 45 to each of the angles, P and R are both 45 degrees, and Q and S are 3 times 45, which is 135 degrees. Notice, too, that I totaled the sum to 360. A quadrilateral with 4 sides has a sum of 4 minus 2 times 180, so 360 degrees. The next 2 examples that we're going to look at here move kind of away from polygons and just to some review of some algebra properties. Later on in this unit, we're going to look at some polygons in the coordinate plane. So it's going to be important that we understand how to calculate the distance between 2 points in the coordinate plane or the midpoint between 2 points in the coordinate plane. So for the midpoint, of a segment AB with endpoints A, x1, y1, and B, x1, y2, the formula for the midpoint M is x1 plus x2 divided by 2. That's the x coordinate of the midpoint. And then the y coordinate of the midpoint is y1 plus y2 divided by 2. So it's really just an average of the coordinates. So to get the x value that's halfway between x1 and x2, we find the average. So we add them up, x1 plus x2, we divide by 2, and that's going to give us the middle x value. We do the same for the y value. So add up the 2 y coordinates, and then find their average by dividing by 2. Distance formula is a little bit more complicated, but it's actually really just derived from the Pythagorean theorem. It just allows us to do it without drawing a picture and without making a triangle. So the distance between 2 points A and B is equal to, so D for distance, D equals the square root of x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. So the distance between 2 points, if you can kind of visualize this, I'll do my best to draw a picture here, but the distance between the 2 points is going to have some x value and some y value. And then the distance between those 2 points is going to be the hypotenuse, like the c. So if c squared is equal to the difference in the x's plus the difference in the y's, we undo that squared with the square root. So this formula right here is really just derived from the Pythagorean theorem. All right, so make sure you have those formulas written down in your notes, and let's go ahead and try some examples. On this first one, we're going to start with midpoint. For the midpoint, it might be helpful if you start by labeling your points. Pick one point to be x1 and y1, I'm going to go with P, and pick another point to be x2 and y2. To find the coordinates of midpoint M, we then just need to add the two x's up. So I'm looking at the formula right here. So add up my x's, 8 plus -5 divided by 2. And then we add up the y's, 9 plus -3 divided by 2. And we want to make sure that we simplify the numerator before dividing by 2. So if I do that, I'm going to get 3 over 2 and 6 over 2. And then if I'm going to do any sort of graphing, it's probably easiest if we convert it to a decimal. And when we do that, 3 divided by 2 is 1.5. And 6 divided by 2 divides evenly to a 3. So the midpoint between points P and Q is the ordered pair 1.5, 3. So if we were to graph these 2 points on the coordinate plane, that point 1.5, 3 would be right in the middle of the segment. Here's a try now for you to try on your own. You're going to calculate the midpoint of segment XY with the given endpoints. Go ahead and pause your video and give that one a try. All right, here when you add up the x coordinates, you get 8. And when you add up the y coordinates, you also get 8. So both the x and y coordinates of the midpoint are 8 divided by 2, which means our midpoint is the ordered pair 4, 4. For our last example in this lesson, we are going to now find the distance between 2 points. So the distance between 2 points is going to be calculated using the distance formula. I'm going to write that here at the top. You have it in your notes. For the distance formula, we take the square root of the change in the x's, quantity squared. So how far apart are my x coordinates? And then how far apart are my y coordinates? And that's like giving me my A and my B. So if you can picture 2 points, the difference in the x coordinate is one of the values, the A. The difference in the y coordinates is the B. And the distance between the points is the C. So if I take the difference between the x's, x2 minus x1, plus the difference between the y's, y2 minus y1, I'd have a squared plus b squared equals c squared, where c is the distance. So I got to undo my squared with the square root. So really, this formula, again, just comes from the Pythagorean theorem. It's really cool. Let's, though, use this without making the Pythagorean theorem. Let's just label our points here. Again, x1, y1 is one of the points. x2 and y2 is the other. It doesn't really matter which point you pick to be x1, y1, and which one you pick to be x2, y2. You're going to get the same answer. So the first thing we need to do is find the length of the distance between those points. So I'm going to subtract and do x2 minus x1. So that's 1 minus -5, and then it's quantity squared. And then we'll do the same with the y's. So y2 is -8 minus 3. And really, the order in which you subtract doesn't matter. That's just going to change whether it's a positive or a negative. So 1 minus -5 is 1 plus 5. That is 6 squared. And -8 minus 3 is -11. Now, what's cool about this is that the distances are always going to be positive, because when I square something, a -11 squared, that's a -11 times a -11, is positive 121. So we have the square root of 36 plus 121, which adds to the square root of 157. So this is my answer as a radical. Now let's go ahead and get our approximate answer. So if you grab your calculator and you do the square root of 157, and then if you're using a scientific calculator, it helps if you put a decimal at the end so that your calculator kind of outputs the decimal, but what you're going to get is you're going to get like 12.52, and then it keeps going. We want to be rounding to the nearest tenth, which is 1 decimal place, and the 2 here is going to round down. So my approximate answer is it's approximately 12.5. The exact answer would be keeping it in radical form as the square root of 157. Here's a try now example for you to try on your own. Go ahead and pause your video and see if you can calculate the distance between the point -8.4 and -3.7. Please pause now. Here's your solution to the try now. The distance between the x coordinates is 5. And I think it makes sense if you look here. The number -8 and -3 are 5 apart on your number line. And the number 4 and the number 7 are 3 apart on the number line. If you end up getting a negative number when you subtract the difference, that's okay, because when you square it, it's just going to be back to positive anyways. So the order in which you subtract, like whether you do x1 minus x2 or x2 minus x1, it really doesn't matter because we're going to square it anyways. One way will give me a positive, like this way, -3 minus -8 gives me +5. But had I gone the other way, -8 minus -3 would be a -5. But really, -5 squared and +5 squared are the exact same. They're both 25. So the order in which you subtract does not matter, but you need to make sure that you're subtracting carefully. That's it for this video. So thanks for watching and good luck as you practice some problems involving polygons, distance, and midpoint formula. Bye.